how things are going. All right, where did we leave off at? 19. All right, here we go. Find the surface area here. All right, again, we want to try to leave it in, simplified radical form. All right, so surface area here is equal to area of the base plus 1/2 perimeter times the slant height. Very good. So I need help with the area of the base. First of all, the base is a what? So it's going to be 1/2 little b little h plus 1/2 perimeter times the slant height. So what's the base of the triangle? Come on, guys. What's the base of the triangle? Say it again. 1.5. Come on, guys. So now someone tell me the height of the triangle. We've done it 100, maybe 1,000 times. What? Yes, thank you for those who have no clue. 0.75 radical 3 plus 1/2. What's the perimeter? Thank you. 4.5. What's the slant height?
2.5.
2.5. Yes, sir.
How'd you get 0.75?
Because it's an equilateral triangle. It's an equilateral triangle. All right? Because the base is an equilateral triangle, when I draw the height in, it bisects the base and creates a 30, 60, 90 triangle. Did I agree with that? Anybody have any questions? What? What's the what? The perimeter of the base times the slant height. You agree with that? Everybody happy with that? All right, and again, if for some strange reason you forget that formula, there's just 3 triangles that are the sides of the pyramid and 1 triangle for the base. Everybody agree with that? Anybody have any questions? Nobody? All right, so let's simplify that. All right, what's 1/2 times 1.5 times 0.75? Nine over 32. Does that make any sense?
I just wrote it as.
Well, what's 9 divided by 32 as a decimal? Is that right? Is that 9 over 32? It's not?
No. Oh.
What?
No, it's 9 over 32.
Oh, 9 for 9 over 32. I have 0.2.
Tell me what, that's what I'm saying.
If you change the
0.75, 3/4, I'm sorry, it was 9 over 16. Is that better? 9 over 16 radical 3
Yeah, that's 0.5.
plus, and then if we multiply that, 9 over 2, 45 over 8. Is that correct? 45. Yes, I'm correct.
Wait, how are you getting fractions?
Okay, so again, I always tell everyone, and I'm glad you asked me that. Seriously, guys, I want everybody to pay attention. Everybody in there, everybody here should be able to just look at that and tell me it's 9 over 16 and 45 over 8. And if you think you can't, you're sadly mistaken. So please look up. It's so simple, and people think, oh my gosh, how did you do that? Well, what's 1.5? Let's start out with what is 1.5? What fraction? 3 over 2. Not much I can do for you if you don't know 1.5 is 3 over 2. You agree with that? And then I have the fraction 1/2, and then what's 0.75? 3/4. Right? So it was 9 over 16 now. See how easy that is? That's very simple. Very easy. You should be able to do that. That's why I tell everybody it's much easier to work with what? Fractions than decimals. People don't think that because they don't have any clue how to work with fractions. but we do. Just like over here. 4.5, you should be able to tell me is what? You should be able to tell me that's 9 over 2. You should be able to tell me 2.5 is what? 5 over 2. So now you're just asking me what's 1/2 times 9 over 2 times 5 over 2. Does everybody see how ridiculous that sounds? Right? Everybody happy with that now? You see what I'm saying? Why fractions are much easier to work with than decimals. Because I do not want to know what 45/8 is, even though you should know that's what? 5.625. Right? Easy. Easy, easy. Anybody else? All right. With that being said, let's look at number 20. One diagonal of a kite is twice as long as the other diagonal. If the area of the kite is 400, what are the lengths of the diagonals? So, probably forgot how to do this, am I right? So if you forgot how to do it, we can always look up the formula for area of a kite. So what's the formula for area of a kite? Do you remember?
Isn't it like 1/2
Yep.
diagonals?
1/2 the product of the diagonals, right? So again, you have to know that now. Area is equal to 1/2 diagonal 1 times diagonal 2. So we agree with that. Now, what I want to do this is because do I think that's a kind of a silly formula? And the answer is yes. So let's look up, guys. Let me try to show you why that's a silly formula. All right, not the best kite in the world, but does everybody agree that's a kite, right? Well, try to draw a kite anyway. Not very good, but you'll get the point. This right here, is everybody with me? Is, what can you tell me about the two triangles I created?
Equal.
They are equal. So they agree with that. Anybody have any questions with that? So, because there are two triangles, and does everybody agree they're exactly the same? Hey, does everybody agree they're exact same triangle, right? So I could say 1/2 base 1 times, well, not base 1, sorry. 1/2 the base times the height, right? And then we could multiply that by what?
2.
Multiply that by 2. Does everybody agree with that? So essentially it's just what? Base times height. Does everybody agree? So this right here is the what? Base. And that is the what? And that's the height. All right? So again, if we know that this one diagonal is twice as long as the other. So from here to here, help me out with that. What is that? That's x. And then the other one's going to be what? The other one's going to be 2x. Right? So now we have what? We have 1/2 times what? 2x times what? X. And that is equal to what? 400. All right, so be careful with that. So I just have what? X squared equals what? 400. So x is equal to, of course we could say plus or minus 20, right? But we can't have negatives, so x equals what? 20. Everybody okay with that? All right, now if one diagonal is 20, then the other would be what? The other would be 40. All right. Let's see. 21 I thought was interesting, and I think we already did this one, but we'll still take a look at it. I thought it was a great picture. Because they're all what? What are all the shapes there? It is one giant rectangle. But all the shapes are what? Parallelograms, correct? And the parallelogram is what? Base times height. Does everybody agree? So the average kid would just do base times height of 1, 2, 3, 4, 5, 6 different parallelograms, right? But we're smart enough to know the height is always what? It's 102, right? And the height is just what? all those sides added up. All right, is everybody with me on that? So again, the area of that shape is just 102 times this length. Somebody add up that length real quick. How much is it? So 574. So the area was what, guys? I didn't hear you.
58,548.
58,000. Say it again. Sorry.
58,548 inches square.
548 inches square. All right. Any issues? Any issues? Everybody okay with that? All right. So here we go. So 22. The Good Time Company needs to make paper hats to use for special events. The paper hats are in the shape of a cone. The radius of the cone is 8 centimeters and the slant height is 20 centimeters. How many square centimeters of paper are needed to make each hat? So what's the surface area of a cone again? Go. Yeah, pi r squared plus pi r l. I like it. That's the surface area of a cone. Pi r squared plus pi r l. All right. If you don't know that, you need to make yourself a star by make sure no surface area of a cone. All right, but is the cone any different than the pyramid? No. All right, so again, let's refresh. Pyramid, area of the base plus 1/2 perimeter times the slant height, right? For a cone, the base is a what?
Circle.
That's why it is pi r squared plus 1/2. Perimeter of a circle is its what? Circumference. That's how we got the 2 pi times the slant height. The 1/2 and the 2 cancel out. Pi r squared plus pi r l. Forgot the r. All right. See, it's not just a different formula or a bunch of formulas. All right, one formula you can translate. All right, into whatever shape you see. Anybody have any issues with that? All right, so what's the radius again? 8. So I have pi times 8 squared plus 1/2 pi times, what's the slant height?
20.
20. So somebody tell me. Somebody said 224 pi. Anybody agree with that? What was it? Yeah. Yeah, it did. Why did you put the 1/2? Thank you. So it was what again? 224 pi. And that would be centimeters squared. Thank you. Everybody good with that? Pretty easy? All right, here we go. Find the area of the kite. Now remember the formula. You should be able to tell me area equals what? 1/2 diagonal 1 times diagonal 2. How much? 1,640 inches squared. Everybody good with that? What? Go ahead.
Wait, so when you're saying the diagonals, like you add up 26 and 56
Yes.
and 20 and 20?
Yeah. Now, the other thing, like I was trying to say, but I didn't do a very good job in the last one. Do you agree that is the base of the triangle? Come on, look up for a second. Do we agree that's the base? The thing that I just highlighted, is that the base of one triangle? And this is the what? The height. So I could find the area of that triangle and just multiply it by what? Multiply by 2. So it's not really that big of a deal. If you don't remember the formula, 1/2 diagonal 1 times diagonal 2. Yes, sir.
Can you just like do 56 plus 26 times 40 and then divide it by 2?
Yep, of course. Yeah, easy, lots of ways. All right, anybody else? All right, here we go. Find the area of a regular octagon. All right, so if it's a regular octagon, how many triangles are involved?
8.
8. So here we go. So the area is 8 times 1/2 little b little h. Everybody good with that? Right now, if you were going to do this and you weren't 100% sure, here's how you draw an octagon. All right, this is what I'd want you to do, something like this. All right, do I care about the octagon? No, I just care about what? This triangle right here. I care about one of the triangles. All right, now it says the side measures 10. So this guy right here is 10, do you agree? So then area equals 8 times 1/2. What's the base? Yeah, I don't know why I wrote 8. 10. Okay, now the height is something we have to figure out. So we calculate the height by drawing this straight down. So somebody tell me what that angle measure is right there. No, not even close. How much? 22.5 degrees. That angle is 22.5 degrees. An octagon is not a hexagon. The only time you get a 30, 60, 90 is with a what? Hexagon. That's it. All right? Any other shape you have to use trig on. All right, you have to use trig. So that angle is 22.5. So now I'm asking you about this right here. What is this side right here? Come on. 5. All right? I need the what? Height. Yes. So somebody tell me. Tangent of what? 22.5 is equal to 5 over h. So h is equal to 5 divided by tangent of 22.5, which is approximately 12.1. All right, so now we take that answer, multiply it by 10, divide it by 2, multiply by 8. So what's the area of that regular octagon? Somebody? 482 point what? 84, and we could say inches squared. All right. Is that right or not?
I just got 484.
Exactly 484?
Yeah. Oh, okay. I
With 12.1?
Yeah.
So 12.1 is the height, right? So the height goes right here. Right? So it's 8 times 1/2 times 10. Now, some of you guys understand if you round the height and you use that rounding, your answer is going to be different. I'm trying to teach you, use the number in your what? Calculator. Don't round until the very end. Don't round until the very end. All right? But do I really care? If you got 482 and someone got 484, I know you're on the right track. All right? It's just a rounding process. That's why you don't round until the very end. All right, let's take a look at 24. All right, let's see if we remember how to do these now. Matt has 2 posters for a science project. Each poster is a rectangle. The length of the larger poster is 11 inches. The length of the smaller poster is 6 inches. What is the area of the smaller poster if the largest poster is 93.5 square inches? All right, let's go. This one should be no problem. No problem. Did you get it? What?
I got 27.7.
27.78. I'm not saying he's right. 27.78 square inches. What did you get?
I got
3.74 square inches. Somebody else. All right. So the larger poster is what? The length is what? 11 inches. And the other one is what? So everybody take your calculator and do 11 divided by 6. That's the ratio of the sides, right? So if that's the ratio of the sides, what do I do to that number? Square it, and that becomes the ratio of the what? Areas. So look at that number. That is the ratio of the areas. Now, what is the area of the poster that's given? Is that the big or the small? It's the large one. All right? And we know that because we read the question. So how do I get to the small?
Divide.
Divide it by that answer on your calculator. All right, again, to me, that is obvious.
Or 27.
What is it?
27.
Yeah. 27.81. So let's clear this out. Does everybody agree? 27.81? Like I said, I don't know. You guys are doing it with your own calculator. Everybody happy with that? All right, 26. Something else. All right, come on. Everybody do this one real quick. Come on, real quick. 26. Everybody do it. Again, you have to know the formula for what? Area of a trapezoid. What did I tell you the formula for area of a trapezoid is? Say it. Yeah, average of the bases times the height. Average of the base. I know exactly what you meant. Average of the bases times the height. All right. Do we have both bases? Right. So again, we're just filling in. 1/2 15 plus the other base times the height is equal to 2400, right? Half of 40 is what? 2400 divided by 20 is what? It's not a calculator problem. So your base is how much? 105. The base is 105. Everybody good with that? Everybody good? All right, 27. The 8-sided figure below is divided into 5 congruent squares. The total area of the 5 squares is 125 square inches. What is the perimeter? How many questions are there?
I think there's like 60.
How many?
There's 57.
57. Okay. Anybody have any issues? What's the answer to this one? How much? Somebody said 60. Yes, ma'am. Yeah, so the area of one of the square, or the area of all the squares is 125, right? So that means if I divide that by 5, the area of each square is what? The area of each square is 25. Which means that each side is 5, correct? So now to me it's just a matter of counting up the sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Uh-oh, which one did I miss? Yeah. 12. Thank you. I don't think that was that bad, right? 60 is the perimeter. Good enough? All right, let's try. Oh, yeah, these are good. Area of a sector. What's the formula for area of a sector? Wow, that's not sounding good, guys. Area of a sector. Tell us.
What's the area of the circle?
Yes, that's it. That's all I want you to say. It's the area of the circle, right?
Times 164 divided by 360.
Pi r squared. That's the area of the whole thing. Do you agree? But we only want a fraction of it. So it's pi r squared times n divided by 360. That's the area of a sector. Come on, that's not hard to remember. If you know the area of a circle, you know the area of a sector. It's just the fractional parts. So again, area equals pi times 15 squared times 164 out of 360. Chop, chop. Go. I'm listening. Anybody else? Come on now, you guys. Do it on your calculator, guys. All right, help me out, guys. I'm telling you, you're going to be sorry if you're not doing it now. All these questions are going to possibly be on the test. All right, I'm not putting any formulas there. None. Zero. What?
Can you like keep pi?
Oh, I actually should have done that. Thank
So I got
you. Yeah, I should have done that.
2.5.
So is that approximately or as the fraction? I mean, is it just exactly 0.5?
Yes.
Yes.
So write it as a fraction. Tell me what that fraction is. Did you say 102 and a half?
Yeah.
So what is that? 205 over 2? Yeah, 205 over 2 pi. All right, that's really what I want. Sorry, I wasn't thinking. 205 over 2 pi. Take your calculator out. Do 15 squared times 164 divided by 360. Math, enter, enter. That's your answer. Yeah. And I should tell you 205 over 2. You see what I'm saying right now? Again, I'm not, because that's the formula. But again, I understand. Let me say it one more time. Look up on the board. Because again, I always am telling kids, I want it to be as obvious for you as it is for me. Right? So I'm asking you, look up, Dalton. You see what I'm saying, right? Do you agree if I asked for the entire circle, it would just be pi r squared, right? But I don't want the whole circle. I want how many parts of the circle. What part is that? How many degrees? Out of how many? That's why that is. I'm only taking a part of it. And I always tell kids, think about it if I said, what's the area of a fourth of the circle? Right? You just find the area and then multiply by 1/4. What I really said is, what's the area of a 90 degree? So it's 1/4. How do I get 1/4? 90 out of what? 360. Okay, is that better? All right, come on, guys. I'm trying to encourage you. Understand. All right, if you don't memorize the formula, that's okay. You can still figure it out. I don't want you to memorize that formula. I just want you to say, hey, I know the area of a circle. And all it is just a part of the circle. All right? So now down here, they're telling you to find the central angle. So we say in this case, what? 94 equals pi. What's the radius? 14 squared times n over 360. Remember that. Okay, so now take your handy dandy calculator and we're just working backwards. So we're typing in what on our calculator? 94. Then you're going to divide it by pi. Then you're going to divide it by 14 squared. Then you're going to multiply it by 360. And that's roughly what?
54.
Somebody said about 54. Right? 54 point what, tell me? 957 degrees. That angle is roughly 54.957. Now, do we measure degrees with pi in there? No. So that's why you just go ahead and divide it out. Now remember, if you're not sure, I'm telling you, I'm trying to help you be better with your calculator. Learn how to use your calculator properly. Everybody comfortable with that? All right, there's really no work if you use a calculator, it's just working backwards. All right, let's just do a couple more because I feel like I'm just going through this. All right, a rectangular billboard casts a shadow on the ground in the shape of a parallelogram. What is the area? If you said 30 times 15, just slap yourself. Go ahead. All right. What is the height? Somebody said 15 radical 3. Who said that? How did you know? How do I know that? Yeah, but not all 90-degree angles are 30, 60, 90. So let's look over here just to make sure. So if this is 30, this already is what? 15. So this relationship is what? Half. So it's safe to say if the opposite leg is half the hypotenuse, it's creating a what? 30, 60, 90 triangle. So she is correct. It is 15 radical 3. But now let's say we forgot. We didn't realize that. All right? Can everybody agree we can at least make the right triangle there, correct? Come on, look up. Because again, most people don't see that. All right, so everybody pay attention. This is 15 times 2, right? This is 15 times 1. So this has to be 15 times something. Does everybody agree? And we're doing the leg, right? So it's the hypotenuse minus the other leg. So 2 squared is what? 1 squared is 4 minus 1 is, square root of that is radical 3. So that's the other way I'm trying to tell you now. All right, I can't do these problems over and over and over and over. Participate. Make sure you're understanding what I'm saying. And feel free to stop me if you're not sure. I feel like you should know at this stage how to use that. All right, use the 30, 60, 90 triangle in your favor. If not, use the fact that you understand the factors, all right, to make the problem easier. I don't want to do 13 squared minus 15 squared and then have to break that down. I just don't want to do that. All right? So now that we have the height, we now can say the area is 15 times 15 radical 3, which everybody knows is 225 radical 3 square feet. All right? Area of a rectangle is base times height. Everybody good? All right, let's try one more. All right, surface area of the cone. Someone refresh my memory on surface area of a cone. I'm listening. Go. Fight for it. Surface area is pi r squared plus pi rl. You should know that. Come on, come on. Uh-oh. What's the radius? 7.5, right? So instead of doing 7.5, does everybody agree it's easier to write what? 15 over 2 squared times pi plus pi. What's the radius? 15 over 2. Uh-oh. What in the world is the slant height?
6 radical.
Is that the bell, seriously? It's too fast. All right, guys, listen. Obviously, I don't have time to do all of these. All right, tomorrow. So chop, chop. Get some work done. Get some work done, all right? Everybody get some work done, all right?